For example, good morning students. So today we are going to learn about the transition elements property. So these are the learning objectives we will try to cover in this class. So learning objective number 1, we're going to learn the catalytic property of transition element, how the transition elements help the chemical reaction to speed up. And the second chemical property is variable oxidation state. So we're going to learn how transition elements show more than one oxidation state. So the first one is catalytic properties. This is the diagram of ammonia solution, and the smell is very much similar to the urea, and the urea smell is very similar to urine. So you got how the smell of the ammonia would smell. Now why are we learning about ammonia? It's because we are going to learn soon about catalysts, and catalysts used during the preparation of ammonia. So ammonia have lots of other uses. It's used for making fertilizers, and I'm sure we have learned about NPK fertilizer, which stands for nitrogen, phosphorus, and potassium. So you might have already noted that the nitrogen here could be extracted from the ammonia NH3. So in the Haber process, so the first process that we have to learn is Haber process, and the Haber process helps us to prepare, or it tells us to prepare, or it explains how to prepare ammonia. So during the preparation of ammonia, the transition element iron is used as a catalyst. So in this chemical reaction, nitrogen, when it reacts with hydrogen, ammonia is formed. So imagine if catalyst iron is not used. So during that time, the time taken might be around 2 hours. Now if we add catalyst to this chemical reaction, the time may get reduced to maybe around 1 hour, or maybe half hour. So this is the specialty of catalyst, and the catalyst stands for the substance that change the speed of the reaction. So it can speed up the reaction and cut down the time taken for the chemical reaction to form. So here in the Haber process, the catalyst used is transition metal iron, transition metal element iron. Now another process where catalyst transition element is used is in making this powder, and the name of this powder is sulfur trioxide. So sulfur trioxide have many uses. If we just name 2 uses, it could be used in preparing acid, sulfuric acid. In preparing sulfuric acid, we use this sulfur trioxide, and also in making explosives. So you can name any explosive, and one of the component would be sulfur trioxide. So the process for preparing sulfur trioxide is known as contact process. So in the contact process, transition element known as vanadium is used as catalyst. But when the vanadium transition element is used as catalyst, it should be used in the form of vanadium oxide, that is V2O5. This is the chemical equation for the preparation of sulfur trioxide. So you simply mix sulfur dioxide with oxygen and sulfur trioxide is formed. So what do you think this box would contain? Yes, it is vanadium dioxide, vanadium oxide. Now this is a gas, and the name of the gas is, you could guess it from this molecular formula, C2H6. So it is ethane. So ethane is a gas which have multiple uses. It can be used for cooking, heating purpose, also cutting metal, and also welding metals. So the third process that we have to learn is hydrogenation of alkene. Hydrogenation of alkene. So hydrogenation simply means you are adding hydrogen. Adding hydrogen to alkene double bond and converting it into alkane single bond, single covalent bond. So here the transition metal is used is nickel. So ethene, you have double bond here, so it is ethene is converted to ethane single bond, and to speed up the reaction you have used nickel transition element as catalyst. So by now we have learnt around 3 examples of transition element used as catalytic, used as catalyst. The first one is, to recall, is iron. Iron is used as a catalyst in preparing ammonia. Then second one is vanadium, which is used in the form of V2O5, vanadium oxide. And the last transition element that we have learned is nickel, which is used as catalyst in the hydrogenation of alkene. So these are the 3 examples of transition elements which are used as catalysts. So that's all about the first property of transition element that we are going to learn today. Now going to the next one, that is variable oxidation state. By the name itself, you can think about the meaning variable. Maybe it could be multiple, more than one, or many. More than one or many. So other elements, they tend to show a single oxidation state, whereas transition element, they tend to show multiple or more than one oxidation state. Now just to recall, what is oxidation state? You can think for some time the meaning of oxidation state. If you have thought it is a number, you are absolutely correct. There's a number assigned to an atom, the number of electron lost, or number of electron gained, or number of electron shared. So based on the number of electron gained, shared, or lost, the number is assigned, and that number we call it oxidation state. So interesting thing about transition element is they tend to show more than one oxidation state. And the reason is, once the transition elements lose electron, they become unstable. So to become stable, they lose one or more electrons further, so that at the end they so that the transition element may become stable. So during that process, they tend to show more than one oxidation state. So this is the fact about all the elements. All the elements that you have already recognized in the periodic table, it wants to become stable. So same goes to the transition elements. So after losing one, they become unstable. So they lose more electrons in that process. Okay, let's continue. So example to understand this better is iron. You might have already noted that this electronic configuration of iron is a little bit unlikely that we have seen. You might expect 288 and the rest of the number follows to the valence electron. But this kind of electronic configuration, we get it when we write it in the form of SPDF notation. So let's take example of iron with 26 atomic number, meaning 26 electrons. We will write the electronic configuration as 28142. So iron, when it loses 2 electrons from the valence shell, it becomes iron with 2 positive charge ion. And we write the oxidation state of the iron with 2 positive charge ion as +2 or +2. And the electronic configuration of the iron +2, we write it 2814 because the last electron 2 is already lost. Now try to solve this question. Since the iron 2 positive charge is unstable, it further loses one more electron to become stable, and the ion formed is iron with 3 positive charge, and the oxidation state of the 3 positive charge ion would be, so you can guess the oxidation state. If the question is still unclear, the iron, the first example that I have already stated here is atom. So iron atom, after losing 2 electrons, it becomes iron ion with 2 positive charge. And after the formation of iron 2 positive charge, it is still unstable. So to become stable, it loses one more electron. And then we get iron with 3 positive charge ion. So the oxidation state of the atom here, OS, I've just written it the short form for oxidation state. The oxidation state for the iron atom, since it has not lost or gained electron, we can write it as 0. And the oxidation state for the iron ion with 2 positive charge means it has lost 2 electrons, so we can write +2. And this iron ion with 3 positive charge ion, the oxidation state will be, if you have guessed it correct, it is +3. So based on the number of charges that you can identify on the ion, you can also assume the oxidation state directly. So with this, we are done. We are done with today's lesson. So in short, what we have learned is, we have learned that iron, transition element iron, transition element vanadium, transition element nickel act as catalyst. So these are the 3 examples we have learned today. And the transition elements also tend to show more than one oxidation state, and that's because it wants to become stable. So in that process, they tend to show more than one oxidation state. So that's it for today.